Hello students, let's continue exercise 5.1 in this video. Third problem, AD and BC are equal perpendiculars to a line segment AB. Show that CD bisects AB. Okay, so this is the figure. So these two are the perpendiculars. Okay, so perpendicular means it will join the line at 90 degree. Okay, then we have to show that CD. So this line CD is the bisector of line AB. Okay, so this CD line bisect line AB, that we have to show now. So first write the given. AD and BC are two equal perpendiculars to AB. Okay. Then to prove is CD is bisector of AB. So let's prove it. So let's take these two triangles. That is AOD, this triangle, and BOC, this triangle we are taking. Okay. So in these two triangles, angle A equal to angle B. Why? Because it is both are 90 degree. They are perpendicular, no? So it is 90 degree. So both are equal to 90 degree. Then AD equal to BC, that is already given. Okay, this AD is equal to BC, that is given in question. Then angle AOD equal to angle BOC, these two angles. Okay, these two angles are vertically opposite angles. So we know that vertically opposite angles are equal. Okay, so we have two angles and one side. Okay, so one angle, second angle, and this is side. Okay, it is not in between these two angles. So we have to use AAS congruency. Okay, that rule we can say, and these two triangles are congruent. Okay, so these two triangles are congruent means this AO is equal to BO. Okay, because corresponding part of congruent triangle. Okay, corresponding part of congruent triangle are equal. So that's why we are saying AO equal to OB. So O is the midpoint of AB. So if these two parts are equal, then O is the midpoint of that line segment AB. Okay, so O is the midpoint of AB. So CD bisect AB. Okay, so this line, how it came? Why? Because CD line intersect AB at O. So O is the midpoint of AB. That means CD line is bisecting AB. Hence it is proved. Next problem. L and M are two parallel lines intersected by another pair of parallel lines P and Q. Show that triangle ABC congruent to triangle CDA. Okay, so L and M, these two are parallel line, and Q and P and Q are another one parallel line, which is by intersecting the previous parallel lines. Okay, so we have to prove ABC. So this triangle ABC, this triangle is congruent to CDA. Okay, CDA, this triangle. Okay, we have to prove these two triangles are congruent. Okay, so let's start. We have to write given data, which is P is parallel to Q and L is parallel to M, to prove these two triangles are congruent. So let's prove now. Consider the triangle. So in this triangle, angle BCA, that is this angle, BCA is equal to DAC, this angle. Why? Because it is alternate interior angles. When we can say this as alternate interior angle? Why? Because these two lines are parallel. Okay, and this is the transversal passing through the parallel lines. Okay, so taking this as transversal passing through the parallel line. So these two are alternate interior angle. Okay, alternate means one is to the right, one is to the left. Okay, and it is interior. It is between the two parallel lines. That is why we are telling interior. Alternate interior angles are equal. Okay, you would have learnt in the previous classes. Okay, so this alternate interior angles are equal. Same way, BAC, this angle. BAC angle is equal to DCA, this angle. Okay, this is also alternate interior angles. Okay, so these angles are equal. AC equal to CA. Okay, that is common arm. This side is common for both the triangle. Okay, this is common for both the triangles, so you are writing common. So by ASA congruency criterion. Okay, two angles and the side in between these two angles are equal. So we are using ASA congruency criterion and we say that these two triangles are congruent. That is triangle ABC and CDA. Okay, these two are congruent. Then next question, line L is bisector of an angle A and B is any point on L. BP and BQ are perpendiculars from B to the arms of A. Show that triangle APB, okay, APB is congruent to AQB. Okay, these two triangles are congruent, we should prove. First one, let's do it. Okay, so this L is the bisector of angle A. So this angle A is bisected by the line L. Okay, and B is any point on the line L. Okay, and it is some perpendicular is drawn from that point to the arm of A. Okay, so this is one arm and this is another one arm. So it touches the arm at P and Q. Okay, so we have to show that these two triangles are congruent. Okay, let's start. So L is the bisector of angle A and line segment BP and BQ are perpendiculars from L. Okay, then take these two triangles. In this angle P is equal to angle Q. Why? Because both are perpendicular drawn from B to the ray. Okay, so that is perpendicular means what? 90 degree. So angle Q also 90 degree, angle P also 90 degree. So these two angles are equal. Then AB is equal to AB in these two triangles. So if you are taking, if I draw and show you this triangle, in this also AB is common and this triangle also AB is common. Okay, that's why it's common arm. Then angle BAP equal to angle BAQ. Why? Because L is the bisector of angle A. Bisecting means what? It is going to divide into two equal halves. So that two equal halves are equal. That's what we are writing here. Then we see that two angles are equal and one side is also equal. So we use AAS congruency. Okay. So we use AAS congruency to say that these two triangles are congruent. Then second question they asked this one. PB equal to BQ. Why? Because corresponding part of congruent triangle. Okay, CPCT, corresponding part of congruent triangle. So we say these two, that is this side, this, okay, BQ and BP, these two are equal. So it can be said that B is the equidistant from the arms of A. Okay. In seventh problem, AB is a line segment and P is its midpoint. Okay, this line segment is there. In that P is the midpoint. D and E are points on same side of AB. Okay, such that angle BAD. Okay, angle BAD, that is angle A. Okay, this angle is equal to angle ABE, this angle, and angle EPA equal to angle DPA. These two angles are also equal. Show that triangle DAP, this triangle is congruent to EBP. Okay, so this triangle is congruent to this triangle. We have to show EBP, this triangle. Okay, so these two triangles are congruent. We should show now. Okay, first one let's do it, then we'll go to the next segment. So given P is the midpoint of line segment AB, that is already given in question, and these two angles also equal, that is also given in question. Okay, so we are going to take these two angles are equal, no, that equation we are going to take now. Then add angle DPE. DPE means this in between angle is there, no, DPE. This angle we are going to add on both sides. Okay, so if you add on both sides, that means this full angle APD is equal to EPB, this full angle. Okay, so half we took, when we add it together, we'll get this full angle APD and EPB. These angles we will get. So these two angles are equal. So with that, now we are going to consider these two triangles now. So now just now we proved these two angles are equal. Okay, just now we did in the previous slide, no, that one. Then this AP equal to BP. Why AP is equal to BP? Why? Because P is the midpoint. It is given in the question. Then this angle BAD is equal to angle ABE. This is also given in question. These two angles are also given in question. So we are having this angle and this side and this angle. Okay, so angle, side, angle, that rule, ASA congruency rule, we can say these two triangles are congruent. Okay, which rule? ASA, two angles and in between the two angles one side. Then we can say ASA congruency, these two triangles are congruent. Okay, so one more subdivision you have, that is AD equal to BE. Okay, so AD is this one, BE is this one. Okay, AD is equal to B. Why? Because corresponding part of congruent triangle. We already proved these two triangles are congruent. Okay, so these two sides are corresponding sides of the congruent triangle. So they are also obviously equal. Okay, so that's all for this video. Thank you, children.